Hello everyone, this session I will be discussing how to transform a given equation without knowing the roots of the equation, and the transformed equation roots will be related to the roots of the given equation. For example, suppose a biquadratic equation given, you have to get an equation whose roots are square of the roots of the given equation, or roots are reciprocal to the roots of given equation, or roots are increased by the factor 10 from the given equation, or reduce it by a factor 8, or multiply the roots of the given equation by a constant 6. So all those things we will be discussing here in transformation of equations. Then question is why this transformation is required. The problem is with the given equation. Given equation roots are not easy to determine. It's not very easy to predict the nature of the roots. So by transforming the equation into another form, we can predict the roots of the given equation. Even if I tell you a cubic equation roots given alpha, beta, gamma, you find the product alpha cube plus 2 into beta cube plus 2 into gamma cube plus 2. Then in the previous session I told you how to get it, but not this kind of expression. Simple expressions will be expressing in terms of sum of the roots, sum of the product of the roots, and product of the roots taken 3 at a time, all at a time, whatever, in the given equation, and then you find the value. But here, this method will tell you how to get the answer quickly. Just let me tell you one thing. Suppose a polynomial equation is given in the form px equal to a0 x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2, this way up to an. You want to have an equation px equal to 0. You want to have an equation whose roots are m times the roots of the equation. Or problem is like this: form an equation whose roots are m times the roots of the above given equation. How to proceed? You will take the help of another variable, frame the equation in terms of that variable. Variable for this one is x. Let the variable of new equation we are going to form be y. Let y equal to m into alpha, or you take m into alpha I, or simply alpha, where alpha is the root of this equation. Let alpha be a root of px equal to 0. Actually, this alpha is representative of all the roots. In the nth degree equation, n roots are there, alpha 1, alpha 2, alpha n. Then you have to get the equation whose roots are m alpha 1, m alpha 2, m alpha n. The chosen variable for the new equation going to be y. So you have to frame an equation in terms of the variable y. Then we can get the equation whose roots are m times the roots of this equation. So y equal to m alpha, therefore alpha equal to y by m, alpha equal to y by m, since alpha is a root of, I told you alpha is the representative of all these roots, alpha 1, alpha 2, alpha n. Since alpha is a root of px equal to 0, therefore p alpha 0. This implies a0 y by m to the power n, a1 y by m to the power n minus 1, a2 y by m to the power n minus 2 plus an equal to 0. Now what you will do here, you multiply both sides by m to the power n. This will be a0 y to the power n, a1 m plus this way an m to the power n equal to 0. Now see the given equation. Given equation a0 x to the power n, a1 x to the power n minus 1, a2 x to the power n minus 2. You have multiplied the roots of this equation by the factor m. So you have multiplied those coefficients by what? 1, because this one remains the same, only variable is changed. So 1, second one coefficient by m, third one by m square, fourth one by m to the power n. It continues this manner. In a problem, suppose you are given an equation of the form x cube plus half x square 5 by 36 x 7 by 72 equal to 0. And the question is multiply the roots of this equation so that the fractional coefficients may be removed. What we have seen, if you multiply the roots of equation by the factor m, then this coefficient will be multiplied by 1, this one by m, this one by m square, this one by m cube. Now your problem is to multiply the roots of this equation by the factor m in such a way that all these coefficients becomes integer. How is it possible? Go by triangle method. Multiplying by 2 will not help. Why? Because this, when you multiply by 2, this is removed, but this one not. This one also not. 3 also, if you multiply by 3, not possible. 4, no. Because 4 into 2 okay, but 4 into 5 by 36, no. Not removed. Now, if you multiply by 5, it is quite impossible. So multiply by the factor m, which is actually equal to 6. If you say that, how will I find it? Either do it by observation. Why? Because if I multiply this by 6, this fraction will be removed, it becomes integer. This will be multiplied by m square equal to 36. This one m cube, 216. All those are getting removed. So multiply by the factor 6. The equation will be x cube 1. I am multiplied by 1. This one by 6. This one by 6 square. This one by 6 cube. This I have done by observation. Okay, into nothing equal to 0. Now see the transformed equation. So x cube plus 3x square 5x 216 by 72, that is 21 equal to 0. This equation roots are 6 times the roots of this equation, and that was the requirement. Fractional coefficients may be removed. We are multiplied by the factor m. What you can do here, alternative method is there. You assume that if you are not able to decide, you have got an equation whose roots are m alpha form. Okay, m into alpha form. Then you make the leading term coefficients 1. From there you get the value of m. Doing it by observation is always advantageous. Now the problem is to find the equation whose roots are double the roots of this equation. This is just another example. You start this manner. Let y equal to 2x. So x is what? Y by 2. Substitute there. 32 into y by 2 cube. 14 into y by 2 plus 3 equal to 0. So 8y cube minus 7y, and this 8 will be multiplied plus 24. No, not 8, it get cancelled fully. So it will be 7y plus 3 equal to 0. This equation has roots double the roots of this equation. Okay. Find the equation whose roots are reciprocal to the roots of this equation. How do you get it? This is the given equation. You let y equal to 1 by x. So x is, it will be in terms of new variable. So 1 by y to the power 4, 4 1 by y cube, 5 1 by y square, 8 1 by y plus 5 equal to 0. So this will be 1 minus 4y, 5y square, 8y cube, 5y to the power 4 equal to 0. This is the required equation. How does transformation of equation help in this case? Given that alpha, beta, gamma are the roots of the equation, find the equation whose roots are this, this and this. Two questions I have asked here. How to get it? You cannot find the sum of these the way you did it for quadratic. Some of the products taken 2 at a time, some of the products taken 3 at a time, or product of roots. So what to do? Better transform. We frame an equation whose roots are of this form. You target one of the root, express in terms of one of the root of the equation. Since alpha is a root, it will satisfy the equation alpha cube p alpha plus r equal to 0. Okay. Now let us assume y equal to 1 by beta plus gamma minus alpha. If you get y entirely in terms of alpha and substitute there, then this becomes the root of the transformed equation. Got the point? I am transforming the roots of this equation of this form, so that the resulting equations have roots of this. All these are symmetric functions. Okay? In place of alpha, if you replace beta, or alpha if you replace gamma, you get roots of that form. They are all symmetric form. So you can get it quickly by taking y equal to this thing. Now for this equation, for this given equation, alpha plus beta plus gamma is 0. Alpha beta, beta gamma, gamma alpha equal to p, and alpha beta gamma equal to minus r, you know. Therefore, y is going to be what? 1 by alpha plus beta plus gamma minus 2 alpha, agree? And here alpha plus beta plus gamma is 0. 1 by 0 minus 2 alpha. So alpha is what? Alpha is going to be minus y by 2. Now alpha satisfies the equation. So put alpha equal to minus y by 2 there. It will be minus y by 2 whole cube p into minus y by 2 plus r equal to 0. So minus y cube by 8 minus py by 2 plus r equal to 0. This implies minus y cube minus 4py plus 8r equal to 0. That is y cube 4py. This equation has roots of this form. What are the roots? Alpha, beta, gamma are the roots of the given equation. Now this equation has roots of the form 1 by beta plus gamma minus alpha, 1 by gamma plus alpha minus beta, and 1 by alpha plus beta minus gamma. Now question may arise apart from this. Suppose they have asked you to find this product of this thing. They have given that alpha, beta, gamma are the roots of this equation. Now get the value of this product 1 by beta plus gamma minus alpha into this. How do you get it? This equation's root we got. This equation's root are of the form 1 by alpha plus beta minus gamma, 1 by beta plus gamma minus alpha in that form. So if roots of this equation are of this form 1 by and 1 by, then product of the roots will tell you, product of the roots of this equation will tell you the value of this product. So if the question arises, find the value of this product here, this into 1 by alpha plus gamma minus beta, then this is going to be equal to 8r. How easily you can get this product, you won't believe if you don't apply transformation of equation. So you need to know transformation equation, you need to apply for a given sum if required. Now let us go for the second part of the problem. Find the equation whose roots are of this form. So those are the conditions. Since alpha, beta, gamma are the roots of the equation, so these three conditions are valid always. Now the way I got previous one, I found the equation whose roots are of this form. Similar manner I will be doing part 2 also. You assume that let y equal to 1 by y equal to alpha by beta plus beta by alpha. Our aim is to express the right hand side in terms of one of the root of that equation. Maybe alpha, maybe beta, maybe gamma. Whatever, they will obey the relation. They will satisfy this equation. So if I put this value over there, it is coming nothing. Let us simplify it. Or y equal to alpha beta, alpha square plus beta square. But this thing is what? Alpha plus beta whole square 2 alpha beta by alpha beta. Now what is alpha plus beta? This gives alpha plus beta equal to minus gamma. So put it there. So y is going to be gamma square minus 2 alpha beta by alpha beta. Separate, it is going to be gamma square by alpha beta minus 2. Therefore, gamma square by alpha beta is going to be 2 plus y. But we haven't got gamma exclusively in terms of y. Alpha beta is there. I will be using the product of 3 roots over there. What is alpha into beta? Alpha into beta into gamma minus r. Put it there. Therefore, gamma square by minus r divided by gamma equal to 2 plus y. Therefore, we get, this is not 2 plus gamma, it is 2 plus y. Therefore, we get gamma cube equal to minus r into y plus 2. Now gamma expressed explicitly in terms of the roots, in terms of roots of this equation. One root is involved, that is gamma, and in terms of y. Now gamma is the root of this equation, so it will satisfy the equation. Now since gamma is a root, as gamma is a root of x cube plus px plus r equal to 0, so it must check the equation x cube px plus r. So we get gamma cube p gamma plus r equal to 0. So gamma cube plus r equal to minus p gamma. I need to remove gamma. I need to put gamma over there. So gamma cube is there, we can easily put, but here no. So we make cube of both sides. Cubing, we get gamma cube plus r whole cube equal to minus p cube gamma cube. Okay? Therefore, now put the value. Gamma cube is what? Minus r y plus 2 plus r whole cube equal to minus p cube r y plus 2. Okay? Or this you write minus ry minus 2r plus r minus r y cube equal to r p cube. Just a minute, we cannot make it, it will remain the same form, minus p cube, no, this was minus r minus minus, yes, it is plus r p cube into, here gamma cube you have taken, so simply you put this thing. So required equation going to be, required equation is r cube y plus 1 whole cube plus r p cube y plus 2 equals. You can arrange in the form of y. It will be cubic of y. This equation has roots of this form. What form? Alpha by beta, beta by, plus beta by alpha, beta by gamma, gamma by alpha, gamma by alpha, alpha by gamma. Okay? Again, if they have asked to find the value of this product, this into this into this, then your answer is here. Just get the absolute term, it will be the product of the roots. Okay? This sum going to be, what to say, important one. I cannot say important or not, but the way I will be solving is important for you. Okay? Transformation of equation, this kind of problem is, knowing the method is important for you. How to answer this? Roots are of this form here. It is bit complicated. Because of alpha beta plus alpha beta gamma are the roots of this equation, so alpha plus beta plus gamma will be 0 here. Alpha beta, beta gamma, gamma alpha is minus 1 and alpha beta gamma is minus 2. If we start the way we did all other sums, then we let y equal to, it is said that form an equation whose roots are squared difference of the roots of this equation, means roots are alpha beta gamma. Frame an equation whose roots are alpha minus beta whole square, beta minus gamma whole square and gamma minus alpha whole square. You let y equal to alpha minus beta whole square. Therefore, y equal to alpha plus beta whole square. What is alpha plus beta? It is minus gamma, and 2 alpha beta is what? This implies alpha beta is minus 2 by gamma. Substitute there, minus 2 into minus 2 by gamma. Therefore, y equal to minus gamma square only, and oh no, sorry, this will be minus 4, extremely sorry. This is going to be gamma square plus 8 by gamma. Therefore, gamma cube plus 8, nothing you got. Because if you cannot express gamma exclusively in terms of y, then it's of no use. So what to do? You got the equation, you got it in terms of gamma cube. It is going to be gamma cube minus gamma y plus 8 equal to 0. You got this. But gamma you are supposed to express exclusively in terms of y. Not possible here. But you make an observation here. Gamma is a root here. Gamma is a root. Therefore, we get gamma cube minus gamma, and this will eliminate gamma cube from two equations. Isn't it? Now you subtract. Just subtract. This is going to be gamma into 1 minus y plus 6 equal to 0. So gamma will be 6 by y minus 1. Clear? Now gamma is the root of this equation, so it will satisfy that. Already I have written and got the value of gamma here, 6 by y minus 1. So substitute there. 6 by y minus 1 whole cube minus 6 by y minus 1 plus 2 equal to 0. 216 minus 6 y minus 1 whole square. This implies you just arrange in the form of y here. It is 2 into y cube minus 6 into y square minus 2y plus 1 equal to 0. So this is changed to 216 is also there. So 2y cube minus 6 plus minus 12 y square, 6y plus 12y, 18y, then 208, because minus 6 minus 2 minus 8 gone, 208 equal to 0. Okay, divide both sides by 2, you get the required equation. So y cube minus 6y square plus 9y plus 104 equal to 0. This equation has roots in the form alpha minus beta whole square, beta minus gamma whole square, and gamma minus alpha whole square. Just showing you one more example of this category here. Alpha, beta, gamma are the roots of this equation. Frame an equation whose roots are of this form. You will be doing the same manner. You just write alpha plus beta plus gamma equal to minus 3 by 2. Sigma alpha beta is going to be minus 1 by 2, and product is going to be 1 by 2. And you start the same manner. Let y equal to alpha by beta plus gamma. So alpha by alpha plus beta plus gamma minus alpha. What is alpha plus beta plus gamma? That you substitute here. Minus 3 by 2 minus alpha. Cross multiply y equal to alpha. Therefore, minus 3y by 2 equal to alpha into 1 plus y. So the value of alpha going to be equal to 2 into 1 plus y. Now alpha is a root of this equation again. Since alpha is a root, therefore 2 alpha cube 3 alpha square minus alpha minus 1 0. Put the value of alpha over there and arrange in the form, arrange in parts of y. So 9y square by 4 into plus 3y by 2 into 1 plus y. Just simplify and arrange to get the desired equation. Okay, next session I am coming with some excellent problems based on this and those ISI CMI problems. Thank you.